only, and then one picture I pass out to you, and it's just this on that page. And then you have the notes page where it's really small in there. So we're going to use it again. So I want to talk about this. So an object is shot straight up into the air.
Yeah.
What is the path? How do we name the path? What does the path look like? So can we use another word for that? Parabola. Makes the shape of a parabola. So it goes up, and then it comes back down in the shape of a parabola. Okay. So these are called projectile problems. So my x-axis in these projectile problems is going to be time. So on that paper, you might want to put x-axis is time. And then your y-axis is going to be height. So on our y-axis, we're going to find height. So you can either start here, shooting it from the ground, or maybe down over here, starting from the ground, or you can start up above the ground. So say we started up above the ground. This point here is the y-intercept. How high off the ground did the object start? Okay. So what part of the graph will be the maximum? The vertex. So we're going to look at that vertex, which is here. The x value of the vertex or the y value? The x or the y is the maximum value. The y, so here's that. Y value, how high does the object get? And then the x value tells you when is the object at the maximum height. So if you had a question that asks you when is it at the maximum height. So 0. We want to know when the object hits the ground. So when the object hits the ground, what's the height of the object? 0. Okay, so that's why it says 0. So you have a 0 as your height. And so that's going to be when did the object hit the ground, or how long was the object in the air? Because the object goes into the air and then it comes down to the ground. What makes it come downward? And then what acts on that object to make it move down to the ground? Gravity. So gravity pulls that object down to the ground, right? Okay, so we're going to talk about gravity in that equation a little bit. Oh, wait a second, one more thing. So notice on this one we have a full parabola here. So this 0 in this full parabola would be negative. No. So it doesn't make sense to have 0 to a negative time. Like a time of -3 seconds. Would that make sense? So I see a couple of you shaking your head no. So no. So this here and all the way down here for most of the problems that we're doing will not be relevant. So we throw it out if it's negative because it doesn't make sense in the problem. Okay, so let's talk more about so this is an equation that we use for projectiles. So we have h, which is the height, and then this -16 comes from both, we're looking at feet in this problem, and we're talking about gravity. So this would be, I'm just giving you this information. You don't need to know it. You just need to know the -16. It's a 32, and for the gravity, we take a -half of that, and then it becomes a -16. If you take physics, your physics teacher will talk a lot more about projectile motion. So this v sub 0 is velocity at time 0. Or initial velocity. So the h sub 0 is going to be your initial height. So JJ gets a new Android phone for the holidays. He's so mad it isn't an iPhone that he drives to school, goes to the top of the admin building, which is 48 feet tall, and throws it straight up and over the edge of the building with a velocity of 32 feet per second. What is the initial velocity? I don't even try. So we're just reading in this problem, what is the initial velocity?
32 feet.
32 feet per second. It's right there in the problem. 32 feet per second. So what's the initial height? 48 feet. So what you will need to be able to do is to plug these two into this equation here. Okay, so we have capital H, our height, is equal to, we want to put in our, we're going to leave the negative 16t squared. So instead of having an x, we have a t for time. Okay, so we want to put our velocity in here, where the v is. So this would be plus 32t. And then we want to put our initial height where the h sub 0 is, so that would be plus 48. Does that make sense?
Yes.
Okay. So now we want to find the maximum height of the phone. So how do we find the maximum height of the phone? What do we do to find the maximum height? What are we doing on Friday? This is in standard form, right?
After that, we do the A/B thing.
We're going to use an A and a B. It's x equals, in this case, it's really a t, negative.
2.
There's a B, there's a 2, there's an A.
2A.
Negative B over 2A. So our A is negative 16 and our B is 32. So it's negative 32 over 2 times negative 16. So when you're putting this in your calculator, you have to simplify that bottom first. Okay? So that bottom here, 2 times negative 16, what is that equal to?
Wait, say it again?
2 times negative 16, what's that equal to? Negative 32. So what's negative 32 divided by negative 32? 1. So we want to find the maximum height. This is going to give us our x value of our maximum height. We want to find the y value, right, for the maximum height. So what do we do to find the y value?
Plug in 1.
Plug in 1 into our equation. So we have h equals negative 16 times 1 squared plus 32 times 1 plus 48. So feel free to go get a calculator. I'm going to call on a random table and ask you guys to give me the answer. Get up and get a calculator.
I'm running up on poker. I mean, I'm on the poker.
I'll do a negative 1.
That's second.
Oh, shut up. That's your answer. Alright. It's okay.
Okay, we switch over here. What do we get for our maximum, or excuse me, for the maximum height? Why don't you put it backwards? 64. So 64, what?
64.
64. It's a height, so it's 64 feet. Okay, so now my next question, how long does it take the phone to reach its maximum height?
2 seconds. I don't know.
Did we find the time it takes the phone to reach its maximum height already? What part out of the graph is the time it takes the phone to reach its maximum height?
Now we're gonna divide it.
No, so if we are asking,
Oh, so it's 2 seconds.
so we are asking for this point, what about that point? The x value or the y value?
Wow.
We already found the y value, that was the maximum height. You want to find the time it takes to get to the maximum height, so would that be the x value or the y value?
Oh, the X value.
The x value, did we find that already?
Yeah.
Yeah, what's the answer? 1 second. Wow, how? So we want to know how long it takes to land on the ground. So what part of this graph are we talking about?
Bottom.
You add y, 0.
This here, so this point right here. So what's my y value at that point? 0, because my height of my object is 0 when it reaches the ground, right? So I said 0 equal to negative 16t squared. Was it 32t?
Oh, yeah.
Plus 48? Let me just double check that. Yeah. Well, how do we solve that?
Just do what we did.
We do to solve it.
Sorry.
So we learned a number of ways last test on how to solve a quadratic. This is a quadratic, right?
Yeah.
So we can solve it by factoring, we can solve it by quadratic formula, we can solve it by square roots. We can't use square roots. We prefer to avoid the quadratic formula. We want to factor it.
That seems like a lot of work.
So what do we do first to factor this?
Divide by negative 16.
We're going to factor by negative 16. So we're going to factor out a negative 16, and we get t squared. Negative 16 times what is 32t?
2.
Plus or minus?
No, minus.
Minus 2t, because, why is it minus, Cohen?
Because negative times negative makes it positive.
That's right. And then negative 16 times what is 48? Negative 3. So then what do we do next to solve that? We want to keep factoring this here. We just factored out a greatest common factor. How do we factor that? Quadratic polynomial, right?
A couple times.
We've been doing a lot of that, which is what? How do we factor that?
You just
Give it to 16.
once you do it to the x.
Yes, we're going to do the x. What number goes on the top? What number goes on the bottom?
1 and negative 2.
So negative 3 and what multiplies to negative 3? That's okay. I like that he's thinking. And negative 2. What multiplies to negative 3 that adds to negative 2? Negative 3 and 1. So we have 0 equals negative 16 times t minus 3 times t plus 1. What's my next step to solve this? What do we do with that negative 16?
You divide it.
Write it out. We want to get rid of it.
So it'll be 16.
So 0 equals t minus 3 times t plus 1. What next?
Yeah.
You see, you're getting bullied, bro.
How do we solve that?
You want to, what's it called? Do the 0 factor.
Yes, we're going to use our zero product property. 0 equals t minus 3. Sorry. T minus 3 equals 0. And t plus 1 equals 0. What do we get for our answers?
We get 3, negative 1.
Okay, one of those answers doesn't make sense. Which one doesn't make sense?
Negative.
Yes, we can't have a negative time. So our answer is 3 what? What's the units?
Feet per second.
Remember that T is time, so it's 3 seconds. Yes, 3 seconds. Okay, can I get some,